So this short video is about extending what we learned with factorising to extending it to the reverse of binomial expansion, if you like. So we're factorising binomial pairs. So the learning goal is once again using our knowledge of factors to simplify those expressions and equations. So sometimes what we do this time is consider that the highest common factor is not a single term, it's sometimes a group of terms or an expression itself, such as x plus 3. So what we're looking for is where that fits in as a common factor. So here's a couple of examples of partially factorised expressions, and you can see here that x plus y here, let me just highlight that for you, this bracket here is the same as this bracket here. So that's a factor of each of those pairs. Same here, a take 3b is common to this one here. So this is the process we're looking at. Let's look at those individually. So the highest common factor in this case, 5 and 6b have no common factors other than 1, which is not useful. But this bracket here is common to both because there's a multiply sign here and here. So what we do is factorise by x plus y, that's our highest common factor. So we take that out, and what's left when we divide by x plus y, cancels these bits out, we're left with 5 here and the plus 6b here. So that makes our second bracket. Second example, the highest common factor is this a take 3b. Don't forget that that's actually take 1 outside of that bracket. That's going to be important when we factorise. So there's our highest common factor. We take that as a common factor, we're left with 2b. We take that one out as a common factor, that bracket, we're left with take 1. So when we factorise it, we get a take 3b is the first factor that's what we've divided by, leaving us with 2b minus 1 in the second bracket. So the second set of examples don't have that middle step. We have to actually work that out for ourselves. And the process is really not that different to what we've already done with factorising normal expression, and then this second step included. So what we do is actually consider each of these as factor pairs. So we just look at this factor first, and then we look at this pair second. So that's the process we're looking at. Let's look at them individually now, one at a time. So we're going to factorise 5a plus 10b first. So the highest common factor of that, there's no common pronumerals, but 5 and 10 are a common factor. So what I've done is colour code them here to make it easy to see which pair we're talking about. I'm going to start with the blue one. So as I said, the highest common factor for the first pair is 5. The highest common factor for the second pair, there's no common coefficient. So the only common things there are the C pronumerals. So C is a common factor. And we factorise those pairs. So for the first pair, the blue pair, take 5 out the front, and we divide this by 5, leaving it with A, divide this by 5, that's with 2b. That's a bracket. Over here, common factor was C, so we take it out the front. AC divided by C, the C's cancel out, and we're left with A in the bracket. Over here, 2bc divided by C, the C cancels out, left with 2b. Now if we do this correctly, but we know we can factorise it, these brackets should match. If they don't, we've made a mistake. So now we can continue with the second step. So let's take that to the next page. Our highest common factor now is the bracket, a plus 2b. So from there, that forms one of the brackets, and what's left is the 5 here, plus c here. So 5 plus c, that forms the second bracket. Let's look at a slightly more complex one with many more pronumerals in it. So once again, consider each pair of terms. So I'm going to highlight them in colour again. X take 3y is the first pair, ax take 3ay is the second pair. So what's the common factor here? It's 1. What's the common factor here? It's a. So the highest common factor pair for the first pair is 1, and for the second pair is a. So if we divide through the blue terms by 1, it doesn't change, but it does come out, the 1 does come out as a common factor. For the second pair, the a is the common factor, so we cancel out those a's, leaving us with x take 3y in the second bracket. Now let's transfer that over to the next page. Our common factor pair, same as before, is the bracket. Remember, if that bracket doesn't match, maybe we've made a mistake. So we take that out as a common factor. What's left is the 1 plus a here. How do you check your answer? Same as before, you expand that bracket using binomial distribution. Third and final one, let's have a go at that. Maybe you can pause the video and have a look for yourself. Okay, so this one a little bit different in that there's no obvious factor pairs for this one here. There's no common pronumerals, and the only common factor is 1. Over here, same situation. There's no pronumerals common to both, and no factor other than 1 common. So what we do is rearrange it to try and find some matching pairs. So in this case, I've grouped the 5p with the 15pq, because I can see that 15 and 5 are both have factors of 5, and p is common to both. So it gives me something to work with. And what's left on the right here, the second pair, 6 and 2 have a common factor. So I will be able to do some factorising to simplify this. So let's look at that now. I've colour-coded it again. With the blue ones, common factor is p and 5, so 5p. Common factor, the green second pair, q is not common to both, so it's just a numeric value. Common factor of 6 and 2 is 2. So now we factorise by those. So let's factorise the first pair. We'll take 5p out, so 5p divided by 5p is 1, they cancel. 15 divided by 5 is 3. We'll take the p out, we're left with the q. So that's that bracket. Over here, 6 divided by 2 is 3. The q stays there. 2 divided by 2 is 1. So there's our factor pair. And now we can factorise that because the brackets match. It doesn't matter that the brackets are in different orders, because as we talked about before with the commutative law of multiplication and addition, whether you go 1 plus 2 or 2 plus 1, you get the same answer. And that's the principle here. If you want, you can go ahead and write that in the same order like I've done here. So we factorise that as the highest common factor. We have 3q plus 1 is the factor we've taken out. What's left here is the 5p here plus 2 here. And that's our second bracket. Alright, last one. Mixing it up a bit now. So I've rewritten it. In this case, let's look at the first pair. We've got 3 is a common factor of 3x and take 6. For the second pair, it's negative 6y. Now, the reason we take negative out, if you've got a negative there at the front, you want to use it as a factor as much as possible. And I'll show you why that's really important in a minute. But if we do that, we end up with 3 outside of this first pair. So 3x divided by 3 is x, 6 divided by 3 is 2. And on the right, we're taking out negative 6y. So negative 6 leaves 1 when you divide through, and the y leaves x when you go through. On the right here, 12 divided by negative 6 is 2, or negative 2 I should say, because positive divided by negative, and y divided by y cancels out. Now, if we didn't take the negative out, we end up with this. So let's just consider this second term. So let's say we took out positive 6 as our factor. What's left in the bracket? Positive 6y. What's left in the bracket is negative 1 x, or negative x if you prefer, plus 12 divided by 6 is 2, like so. Now you'll see here, this doesn't quite match what we had here or here. Remember that if you've done it correctly, the brackets should match. You'll notice here that the signs are reversed, and that's what happens when you don't always take out that negative. So it's important we do that. So if we factorise that fully now, the x plus x take 2 is now the common factor, this bracket here. So what are we left with inside the bracket are the other two terms. 3 take 6y. And that's the answer. So that shows you how to factorize more complex expressions using binomial factors.